section 5.4, dividing polynomial functions. And we'll start off with just, a throwback to long division in elementary school. And so if we're taking a look at this 59 divided by 3, we can change that over to a decimal and we'll see that that's approximately 19.67. And so if we wanted to actually perform this division, we would write it like this. And then I would see how many times 3 would go into 5. That's 1 time. 1 times 3 is 3. And then I would subtract and bring down the 9. So 5 minus 3 is 2. This would be 9. Then I would divide again. So 3 into 29, that would go in 9 times. 9 times 3 is 27. Subtract, and we would be left with 2. And so that would be a couple of ways you can write this. You can write this 19R for remainder 2, or you could actually write this as 19 and 2/3, the remainder over the divisor. And these two you'll find are really, really similar. This one's just, exact. And this one is rounded or approximated because we rounded. And so just that is a general reminder of the process for long division. And so we have these steps. We divide, we multiply, we bring down, we subtract, subtract, whatever. You know what I mean? And then we just come back and start the process over again. And so this kind of sequence of steps may be helpful to you while you're working on the more complicated problems. And so like we saw before, we divide. And so another way to look at this, instead of like in this remainder format, like you see here or here, is to write the result as a sum of parts. And so this is the same method you actually use to check your work with the elementary algorithm. And it's formally called the division algorithm. So you'll need to know, because it's in red, you'll be expected to know what I mean when I say use the division algorithm. And so the way we write that is we write the dividend, which is 59, equals the divisor, which was 3, times the quotient, which we found to be 19, plus the remainder. And so you can, verify that this 3 times 19 plus 2 is in fact 59. Now with polynomials, we have to give these a name, and we still call them the dividend, the divisor and quotient, and the remainder. Except we give them these more formal names. We call this one f of x. We call the divisor d of x. We call the quotient q of x. And we call the remainder r of x. So see, those kind of make sense, and we'll get more into that in just a second. So for example 1, dividing a polynomial using the division algorithm. And so, we're just going to go ahead and start. So I'll write it just like this, and I want to divide x plus 2 into this given f of x here, right? So let me go ahead and write this, and staying organized is going to be really, really important with these types of problems. And so when we're working on these, we want to divide the first term into the first term. And so I'm going to do my scratch work over here. This helps me keep track of what's going on. And so I'm going to write this here. Notice the same degree terms are going to stay on top of each other. And then I'm going to multiply, because I just divided. Now I'm going to multiply. So I'm going to distribute that to this. 2x squared times x is going to give me 2x cubed. 2x squared times 2 is going to give me plus 4x squared. And so now what we want to remember, if my internet will stop going out, is our next step, if you look back, is to subtract. And so when we subtract this entire thing. So we're going to subtract everything. And so this is just 0. And then we will have negative 3x squared minus 4x squared, which is going to give me negative 7x squared. And do not forget to bring down the next term. And then remember the steps say to go back. And so now I'm going to divide the first term into this first term. And so just to do my scratch work over here so I can keep track of what's going on, that would be negative 7x. And so that goes here. Negative 7x. And then now that I've divided, I'll multiply. So this will be negative 7x squared minus 14x. And then remember, I want to subtract, so that'll be plus plus, distributing that subtraction, and this will be 0, and then this will be 18x. I'm going to do that in black. So this will be 18x now. Don't forget to bring down that next term. And now finally, we want to divide one more time the first term into the first term here. Let me adjust the size of my pen. Okay. No. All right. And so I'm going to do my scratch work here. That's going to be 18x divided by x, which will just give me 18. And so I'm going to write that here. And then I'm going to multiply. So 18 times x is 18x. 18 times 2 is plus 36. And then I'm going to subtract everything. And so this will be negative 31. That's 0. And so I have a remainder of negative 31. And so I want to go ahead and show you a couple of different ways to express this answer. But first, let's figure out all these vocabulary words, right? So we have the dividend. Remember, that's f of x. And I'm just going to make sure we understand what each of these pieces are. So that's this. See if you can find that in our original problem. Then we have the divisor, which is d of x. And that's going to be x plus 2. Then we have the quotient, which is q of x. And the quotient is 2x squared minus 7x plus 18. And then finally, we have the remainder, which is r of x, which is just negative 31. And so remember above where I wrote the format of the answer when we write this as a sum of parts is actually going to be, f of x equals the divisor d of x times the quotient q of x plus the remainder r of x. And so if you can identify all of these pieces, then this part isn't really difficult. We just kind of plug things in. So that's 2x cubed minus 3x squared plus 4x plus 5 is equal to, the divisor x plus 2 times the quotient 2x squared minus 7x plus 18, and then plus negative 31, which should just be minus 31. And so this is your answer written in the format of the division algorithm. And so there's that. And this is how I'll want to see your answers written, unless I specify otherwise. This is the answer written with the division algorithm. And then I'm going to show you one other way to write it. Algorithm. And then let's see another way to write the answer here. All right, so the other way I want to see it written sometimes is with the remainder r of x over d of x. And so that's where we just write the quotient plus the remainder. And so that would look like this. It would just be 2x squared minus 7x plus 18 minus 31 over x plus 2. So notice this is the remainder r of x, and this is the divisor x plus 2 d of x. So these are the two different ways I may ask you to express your answer, and you'll need to be familiar with both. So you can see here, it picked apart a little bit more. So writing it as the dividend, the divisor, the quotient, and the remainder, that is in the form of the division algorithm. Here's the formal statement of the division algorithm. And one of the key things that I want to add here that we'll see later is if the remainder is 0, then we say that d of x divides evenly into f of x. And that means that both of those, the divisor and the quotient, are factors of f of x. And that's going to come in really handy later. So let's try again. Let's do another example where we do the long division. And this is going to be x plus 1 dividing into 5x squared plus 3x minus 2. And let's write our answer using the division algorithm. And so again, we're going to divide the first into the first. That's 5x squared divided by x. That's going to be 5x. We're going to multiply. That'll give us 5x squared plus 5x. Then don't forget that we're going to subtract everything. And that's going to give me negative 2x. We're going to bring this down, minus 2. And then we're going to divide the first term into the first term again. And we'll be left with negative 2. Then we'll multiply negative 2x minus 2. Remember, we're subtracting, so subtract both terms. And we're left with a remainder of 0. And so again, if we're going to write this according to the division algorithm, we will write 5x squared plus 3x minus 2 equals the divisor times the quotient, but the remainder is 0, so there's nothing else there. So notice this is just the factored form of this. And so if the remainder is 0, then both the quotient and the divisor are factors of the dividend f of x, right? So that's pretty valuable. That's another way to factor something, is using division. And so that is that, okay? All right, so now this one's slightly different. Not really, though. The only difference is we have a coefficient here. And so just to show you one more example, because the long division can be kind of tiresome and tedious, but there's something else that's going on here that I need you to see. Oh, not in this one, never mind. Yeah, we'll just get another example going. So I'm going to divide the first into the first. And that's going to give me 2x squared. So I'm going to put that here, 2x squared. Then multiplying, I'll have 6x cubed minus 4x squared. And we'll subtract and bring down, and that'll leave me with 15x squared minus 31x. Then I'll have 15x squared divided by 3x. It's going to give me 5x, so that comes here. Multiplying everything out, I'll have 15x squared minus 10x. Remember, subtract everything and bring down. And so I'll have 0 here. This will be negative 21x plus 15. And I'm going to be ready to divide again. That'll be negative 21x divided by 3x, which is just going to give me negative 7. Multiplying again, I'll get negative 21x plus 14. And then subtracting everything, I'll end up with a remainder of 1. And so to write this in the form of the division algorithm, remember we're going to write, let me write it in red, we'll write 6x to the third plus 11x squared minus 31x plus 15 equals the divisor times the quotient plus the remainder, which is 1. And so that's all done. These are not factors of this polynomial because we have a remainder that's not 0. So why don't you now pause after several examples and see how you do with the long division and writing it in the form of the division algorithm, and then come back and see how you did. All right, so we should have minus 12x squared plus 20x minus 3 equals 4x plus 5 times 4x squared minus 8x plus 15 minus 78. There you go. All right, so now let's move on to using synthetic division to divide polynomials. And there's a very specific set of circumstances under which you can use the shorthand method of synthetic division. Notice that's in red, so you'll need to be familiar with the term. It only works when the divisor is a linear factor with a leading coefficient of 1. And so that's super important. So it can't be like this last example that I did where there was a 3 out front. It has to be a linear factor. And so what we're going to do is we're going to set up kind of an upside down division sign, and I'm going to take the coefficients of the dividend and write them in order in kind of columns. And then I'm going to place a -2 out here. And the way I get that -2 is I take the divisor and set it equal to 0. And so that's going to be x equals -2, and that's what goes out here. So then we just bring down the first thing, that's 2. Then we multiply. -4, add. -7, multiply again, that's 14. Add, that would be 18. Multiply -36, and add, that would be -31. And so let's write the quotient, right? And so we get the quotient from this, right? So when we divide a polynomial of degree 1, like we did here, into this polynomial, the quotient is going to drop by a degree. And so these are your coefficients. So this will be 2x squared minus 7x plus 18. And then this is your remainder, right? Remainder. So this is your quotient. And so if we were going to write this according to the division algorithm, we would write, x plus 2, and then we'd have minus 31, because this would give us, this would be our divisor d of x, this would be our quotient q of x, and then this would be our plus, our negative remainder r of x. And that's going to be writing your answer according to the division algorithm. But that's a little bit faster. Let's do another one. So this would be -2. And so this would be 4, 10, -6, and -20. So we're going to go again. This will be 4. This will be -8, which will give us 2. This is -4. That's -10. And this would be +20. Notice there's a remainder of 0. And so we can write this in the division algorithm. This would be x plus 2, the divisor, times 4x squared plus 2x minus 10 as our quotient. And so then you see that these are factors of f of x.
Please excuse the interruption. Would all flag football team members please report to the cafeteria at this time? Flag football to the cafeteria. Thank you.
All right, let's do one more example. We'll have a +1 outside the bar. We have -9, 10, 7, 0, and -6. Now, why did I put that 0 there? Notice that in descending order, exponent 4, 3, 2, we skipped the x term. And so we have to put a placeholder there. And then we'll just continue as normal. So this will be -9, 1, 1, 8, 8, adding together get 8. This is 8 again, and 2. So this is our remainder. And then we can, of course, write this in the form of divisor. And then the quotient drops by a degree, and then we just go in descending order. This would be x squared plus 8x plus 8, and then the remainder will be added on at the end. And so see if you can use synthetic division to divide this. And I want you to write your answer in the division algorithm format. And then come back and see how you did. Pause the video, give it a try. All right, so you should have gotten, there's your divisor. Your quotient would be 3x cubed minus 3x squared plus 21x minus 150. And then you have a crazy remainder, which is 1,090. So if you got that, you didn't do anything wrong. Good job. And so then let's use some polynomial division to solve an application. We've seen this before with the box. So we know that volume of a box, take a second while I'm writing this and read, is length times width times height. And so it says the volume of a rectangular solid is given by this polynomial. The length is this and the width is this. Find the height h. And so what we need to do here is we need to kind of write this formula in terms of what they're giving us. So this will be 3x to the fourth minus 3x to the third minus 33x squared plus 54x. That's the volume. So equals the length, which is 3x, times the width, which is x minus 2, times h. And we're going to try to solve for h here, right? So the first step we're going to do is we're going to divide both sides by 3x, right? So we're going to divide both sides by that, and we'll end up with, instead, we'll have 3x and 3x over here. These will cancel out. So these will just kind of like go away, right? So we don't need that. So now let's divide this 3x into each term and get this thing simplified down a little. So we get x to the third minus x squared minus 11x plus 18 equals x minus 2h, right? And we're solving for h. So we can divide by x minus 2 and solve here. So if we do x minus 2 on both sides, that'll cancel and h will be left by itself. So this can just kind of like, this will be gone. And so we just learned a method to divide something like this. So we're just going to go ahead and do that. I'm going to take this 2 and put it here. This will be 1, -1, -11, and 18. Bringing down that first coefficient, this will be 2. That'll be 1, 2, -9. -18. Looks like we have a 0 remainder. That's good, which is what we expect, right? Because we're expecting all this to be factors. And so the quotient is going to be x squared plus x minus 9. And so this is actually going to be your height, right? So because we divided everything out and solved for h, and this is the height of the box. And so now you give it a try and see how you do. If you want to pause the video and come back. All right, so you should have gotten 3x squared minus 4x plus 1 for the length of the rectangle. If not, be sure to ask me some questions about what's going on, see if we can pick apart what's happening. I hope this helps, and I'll see you guys in class.